Hi, everybody. This is Nalini Elkins with Industry Network Technology Council. We are recording this presentation. If somebody can send me a quick note to let me know that you're hearing me okay, that would be just wonderful. You never know with technology, you know. I always like to make sure people can hear you. Hear us. Oh, thank you so much, guys. So, okay, well, let's go ahead and get started. As you guys might know, that we have this vision of IPv6 deployment actually getting done at enterprises. What a concept! So one of the first things, of course, is like, what is IPv6 all about? And sometimes I wish they had just given it an entirely different name, because IPv6 is so different, really, in so many ways. There's just a lot to learn. And so we've spent a fair amount of time thinking about what the changes are, how to get your head around some of this stuff, and then security and applications, and actually trying to help you guys start planning. And I tell you something, people take us up on it, and I'd like to see more of you guys. Just feel free to reach out to us. We're happy to help you. That's the purpose of the organization. And so we are happy to say that we have, collaboratively with our partner in India, IISOC, we have received a grant for this year from ISIF Asia, which is funded by various folks, including the APNIC Foundation. So one of the things that we wanted to let you know is that ISIF also has deployment grants for folks in the Asia Pacific. And so we really encourage you guys to go ahead and start looking at this and start applying, to go ahead and start getting grants. There's a fair amount of money available. And what do you need for that? You need an IPv6 allocation. And of course, you need to be in the Asia Pacific region, and then have a plan to go ahead and deploy it. And, go ahead and send them questions if you have ideas about, what's good, what's wrong. Go up their website, and I'm sure they can help you too. And so, they want to help you roll out IPv6. All kinds of organizations can apply. So this is intended in particular for enterprises, the kind of folks that are on this call, as a matter of fact. So as I say, we really encourage you to apply. So just about 2 words about me. I'm the president of Industry Network Technology Council, and I'm also on the advisory board of our Indian organization, the India Internet Engineering Society. My life has been very misspent, both in developing products, working with enterprises, and lately for the last 10, 15 years, working with folks at the IETF. I'm kidding, of course, a lot of fun. And one of the folks that spends a bunch of time at the IETF is somebody called Rob Nagy, who spoke about DNS last time, and he's going to talk again today. And, I will say that we had a lot of people, say they really enjoyed his DNS presentation. He has just a very good way of explaining things, and we're so lucky to have him. And I'm going to let him say more about himself, whatever he'd like to. He's a great guy. We're very happy to work with him. And so he'll be talking about DHCP v6 now, and then the IPAM stuff next time. Again, the lawyers make us say this, note well, that anything that is said is not, we neither promote any tools or platforms or any specific suppliers, nor do we discourage the use of anyone's products. So on that note, so let me give it over to Rob, and you can hear what you really came to hear. So here we go, Rob.
Awesome. Thanks, Nalini. Let me make sure I'm sharing the actual presenter. And not, there we go. The display and not the presenter. There we go. Let's make sure that worked. Woohoo! All right.
Rob.
Well, and you just said who I am, so we'll just jump right into the second slide. Since last time, I want to make sure we leave plenty of time for Q&A. So welcome, everyone. Thank you for attending. Thank you for the lovely introduction, Nalini, and for all the amazing work that you all do. I want to thank the attendees for showing up. I know you have a ton of things pulling at your time, and I really appreciate you taking time to spend with me. I'll wave real quick, just so you know I'm not some robot. Interaction is the name of the game. So we'll have Q&A breaks. There's about 3 or 4 sections actually this time. They go pretty quick, but we'll have a little Q&A space at the end of each one. If you want to throw a question into questions or into chat, whichever way you want, that works great. We'll take that. I have my good friend Michael is also a panelist today, and he'll be answering questions with me and kind of giving his spin on things. We see things very eye to eye, as Nalini and I do as well. But we'll all be here to field your questions. So who am I? I've been doing DDI, DNS, DHCP, and IPAM for right about 20 years. Before that, I built networks for events. I've been a part of the InteropNet team for all the years. We had a volunteer team. I was in the INET group there doing security. I was the NAC educator for a couple of years. Mostly was doing DNS, DHCP for the InteropNet, and then I became involved in the IETF NOC team for a number of years. I was kind of the on-call engineer, so if somebody couldn't make it to one event, one meeting, sorry, I'm not supposed to call IETF events, I get in trouble for that. One meeting, then I would show up and just kind of pick up the pieces, whether that was routing, whether that was deploying IPv6 on wireless, deploying DHCP IPv6, whatever it was, would show up and be a part of that NOC team. So hopefully I can answer all your questions. Who are you? As Nalini said, this really is targeted towards enterprise, but if you're not an enterprise customer, that's certainly fine. Enterprise, including organizations, government, education, whatever your slice of the world is, that's great. But I will certainly talk about things from that more sort of organizational standpoint. I think a lot gets written into RFCs and into documentation kind of about the generic use case of home to CPE to service provider, maybe to country, to the backbone. But we sort of face a different sort of set of challenges when you're talking about deployment within an enterprise, and some of our interests are sort of almost the polar opposite of theirs, especially when we're talking about security. So I will definitely get into that. But without further ado, let's get rolling. And I'm sorry to do this, but I always start with a bit of a review just to make sure everybody can be on sort of the same page. All right, so quick review. So what is DHCP? And this review is going to be very sort of IPv4 centric. And then I will have the next section right away will be what's different and new in DHCP when you're talking IPv6. So dynamically assigning IP addresses since 1997. I only really bring that up to just kind of say this is something that we've had for a very long time. So a lot of the design considerations, the initial RFCs, the initial packet format, the handshake, were really created at a very different time in what the world and the internet looked like, right? Security was not nearly as big a deal when you talked about network engineering. Sysadmins had way more power. Network teams often were still sysadmins and Unix, admins. So it just really put that in there less to give you the RFC number, but to more give you sort of a history, a time of it. It was an extension of the BootP protocol. BootP actually predates that, but we needed to add more sort of features, concept of dynamics of lease times, of not having addresses forever, need to make it more dynamic. DHCP gives us dynamic addressing, I think you know that, What's more important, and we'll see especially when we start to talk about DHCP in the world of IPv6, is it's all that host configure information for clients. I always like to say, I think of DHCP as sort of almost, you know, some of that initial network automation that we're so hot on now is really what DHCP was built for. Admins, networks were growing to the point where admins couldn't manually go and configure every computer that needed to come on our networks. And we needed a way to automate that, and we had ways to automate it, but we needed sort of a way that the sysOS people could put it right into the computer so it be automated sort of from the get-go without us even intervening for that. We just built a server, the hosts already knew how to do it, and we could have this conversation. So these dynamic addresses typically are assigned out of a range of addresses. I will say, when Nalini and I discussed this, I purposely said the DHCP one in an hour is so hard because the terminology in DHCP is so all over the place, especially when I'm trying to be completely vendor neutral. So we could call it a range of addresses. We could call it a scope of addresses. We could call it a pool of addresses. And all of those terms probably mean something else with a different implementer. It's that additional configuration, though, as I said, that really is what we're going to see is so important when we start to talk about DHCP in the world of IPv6, right? So it's great that we gave these computers IP addresses dynamically, but if we don't tell the client where is its DNS servers, what domain name is it in, where are its time servers, where is it SIP, where is it all of these different services that it needs, where's its call manager, let's say it's an IP phone. All of these things become incredibly important, again, so that we don't, as the network or sysadmin team, have to go and get directly involved, right? We want to keep that sort of ease of getting clients online. From our standpoint, besides the fact that it's way easier for us, although we'll see in v6, the addressing part, we don't really need DHCP for. That was kind of built into IPv6. But global changes, especially around that host configuration, DHCP is going to make it so we can manage it more easily, and it's going to give us more expansion of the kind of things we can sort of preset clients to take advantage of over just what comes in just IPv6. So IPv6 has an addressing mechanism in it, has a limited sort of way to put some host configuration, but DHCP is sort of still that full baked version. It also allows for a more efficient, and I would even say in our world of enterprise, more efficient and sort of trackable use of IP resources. So a lot about what came in IPv6, because it came later when we were trying to have more security, we're trying to have more randomness, trying to have more uniqueness. And that's good in a lot of scenarios, especially when we're talking about CPE. We may want to keep these things where they go in a nice order. They're easy for us, the enterprise admin, to go, oh, it's got this v4 address, it will have this v6 address, and be able to tie some of those things together. And DHCP is going to allow us to do that more than natively using the v6 addressing scheme. But again, we'll talk about that more in the next section. So again, really, IP addresses allocated by a DHCP server, again, focusing more on v4, kind of two ways. One is dynamic. So again, it comes out of this range of available addresses or pool, whatever you want to call it. It's just a sequential number of IPs, and we'll go into that detail in a second, where it gets assigned out of that randomly, pseudo-randomly in v4, more randomly in v6, or statically. So I say, hey, if I see this particular client, I'll always give it this particular IP address. And we call those fixed addresses, or manual DHCP, or static hosts, or host in some. Also, as I said, DHCP built on BOOP, and so we had this ability to lease things temporarily. So we say you can have this address for a specified period of time. The client needs to renew the lease at requested intervals. This allows the server and the client to know how long that IP address is being used by any particular client. It's all done very specifically on timers, and we'll look at those in a second as well. There's always been a permanent lease. It is still a lease, The client still doesn't own the address, but the lease timers are just basically infinite. Interestingly, in most implementations, this is done by setting a lease time of 0. That's how it's supposed to be done, but in most implementations, you set a lease time of 0. There's been some clients historically that notoriously always asked for an infinite lease. That was printers, some early IP phone implementations did that as well. Never a good idea for us, the administrators, to allow that because it messes up the whole first two things. Global changes can be managed more easily, allows a more efficient use of IP resources. So that's sort of the what and the why of DHCP. Let's talk about a couple of the elements of it, and then we'll walk through how it works, and we'll be done with our review. So what are DHCP options? Like I said, hey, what's the default router? Where are the DNS servers, time servers, Win servers, hopefully not anymore, NetBIOS node type, lease times, boot server names, boot file names, TFTP server. That was one particular, it actually was being used by a couple of different vendors, and they actually had different types. And IANA got involved and said, hey, you need to write us letters, tell us what you're using this for, and 150 became TFTP server address. Again, it's a very popular IP phone implementation. We'll actually take a look at where vendors really sort of by standard are supposed to put these sort of vendor specific options, but they're just leveraging this. Well, apparently, hold on one second. I'll just turn off the power strip and now I can say Alexa all I want. I don't remember saying Alexa. All right, my apologies for that. But we'll take a look at that. So these are the DHCP options, or that client configuration information. Basically, they're just data fields. It says, hey, DNS servers, and then there will be some data type, which will tell us how to format it. Provides a way to transmit that client configuration. The options are really coded using a numeric code and a data type so that both the server and the client can agree on what that formatting should look like. The usage, or sometimes you'll see this written as option name, this is really just for you. IANA does define them, but the client and the server don't care if this matches. They just care about the correct option code and the correct data type. So here are, and this is a slightly dated list of the IPv4 DHCP options. I'll come back to this on the more IPv6 centric. There are a lot of them. That's all I'm trying to point out. The other thing that's very interesting is some of these things, the odds that you would ever use them anymore are way old. But as long as there could possibly be one quote server still out anywhere using this, it really needs to stay. Okay, so again, we've got 176 IP telephone. That used to be a sort of just vendor known. IANA now owns that. 150 TFTP server address, again, another vendor. IANA now owns that. These just have to match. The only thing I'll tell you as enterprise people is when you're using a product more than an implementation, like a wrapper of an implementation, you do want to make sure that they have preloaded all of these IANA defined. If not, you may have to go define them and just say what the option type is. But I point out option 43 because this is vendor specific and it's the only option that's really different than the rest, where it's just an option code and then a type. Option 43 is used to embed sub options. And what this does is it lets vendors create their own options and they get nested and encoded into option 43. So option 43 can say, hey, there's this total amount of data, then there's this vendor number, then there's this vendor option code, then there's this data for the code, then there's the next vendor code, and you have to sort of define that all in advance. So this is really where vendors are supposed to stick their vendor specific options, and they can have up to 255 options that all get nested into 43. Just very important to know with your vendor what option number they're using as a sub option of 43. And I will say this, Michael and I have discussed this before, I have yet to ever find a vendor whose sub option that gets nested into 43 is option 43. But there are plenty of vendors whose documentation is horrible and makes it sound that way. So I'll just tell you, I've never found one that actually does that. I've seen people who just use 43 and pretend it's a normal, but I've never seen sub option 43 nested 43. All right, so how does DHCP work? There's gonna be 2 sets of slides to just make it a little easier. So first, we've got a DHCP server. It's got some pool or range or list of addresses, depending on your implementation. It's going 192.168.0.10 to 99, notice the ... So this is what's sort of available to all general clients. Then it has client definitions. Again, these could be listed as fixed addresses or statics, or it could be done by a filter, but it's just things the DHCP server knows about specific clients. So we've got 1 MAC address ending in all 7s, 1 in all 8s, and 1 is all question marks, so that's just everybody else. So 777, it gets a specific address, that's like a static or fixed. This particular MAC gets an extra option. This is actually done with a filter. So it gets the extra option 150, and then everybody else gets this set of options, and they can have any address. So let's throw 3 clients onto this network using this DHCP server. Again, we'll talk more about the whole handshake and what gets done in the next slide. But first, we have our desktop comes online. It's got a MAC address of all 7s. That's something the client sends. And that's something we're going to come back to at the end when we're talking about security. And it says, hey, I'd like an address. And it actually also asks for a list of options. It says, hey, your address is 0.10. That's because they match this MAC address. They get this specific, and they would get back these options. They'd actually get back for almost all implementations any of these options that they asked for. And we'll take a look also later on what the client sends to say what options it wants. There are some implementations out there that ignore what the client asks for and sends them all. It's not really ideal. It means you can't do option overloading. All right, next we got our handy dandy IP phone. It comes on, it's got the MAC address ending in all 8s. It says, what is my IP address? And it gets back 99. Different v4 implementations will walk this IP order either 99 towards 10, 10 towards 99. I will say it got 99. Almost all servers, and by standard, they're supposed to, will try and ping 99. If 99 responds to ping, it'll mark it abandoned and moved on to the next one, 98. There are implementations out in the world that start at 10, try and ping 10. If 10 pings, they mark it abandoned, move on to 11. They work this way. Let me state that's only the first time it ever walks through this. Once you're running and you're 70% utilized, so many of these are taken up and haven't expired that what is given out will look random. It's not random. It's actually a very set flow of, first I see, are there any addresses that are in a free state and don't have a previous MAC, and I'll try those, and don't respond to ping. Cool, you get the first one that matches all of those. Next, if I get all the way through and there's no free address that has no MAC associated with it, then I start and I come and go, is there a free address that has a previous MAC? Meaning a client had it some time ago, that lease expired, but we've used up all our free brand new ones. We need to start reusing those. I will say the order of this is outlined very well. And I know Ralph has done some talks for Nalini, and I don't know if Ted has as well, but the DHCP handbook walks through how this is by standard, by RFC defined really to work. So that's a personal preference. I don't know if we're not supposed to recommend books either or authors, but I'm going to recommend it anyway. Personally, Rob Nagy, Deep Dive Networking, said so. Finally, we've got our printer, which is the Deadbeef 0001. I didn't make this up, by the way. Comes in, this is not this, it's not this, so this is anybody. So they will get whatever is the next address, again, based on that, walking through, based on lease states, free, inactive, and abandoned. We'll walk through, and the next one it found that was available was 62. So just happened to give it that one. So this is kind of on the server side how it works. I configure a set of addresses, and these are just sequential, by the way. Some definitions about clients specifically, and then when the clients come on, my server is good to go. But what does this little communication look like? It's obviously a little bit more detailed than that. So let's go through that quickly, and then we are pretty close to done with our review here. So, got a client, we have a server, client broadcasts, a discover, and we're going to talk about this quite a bit because this is where a bunch of things change because of the way IPv6 leverages IP and layer 3. But because in a v4 DHCP, this client has no address, has no way to create its own address to do this. So it has to start with broadcast. So a broadcast discover sends its MAC address, requests an IP, and as I said, what options it would like. The server is then going to run what we saw on the last slide. It'll go, hey, based on this MAC and where it came from, which network, there could be if we can't reach a DHCP server, by the way, most times, and we won't put it in this picture, it would hit the edge of its broadcast domain, and then that's where your switching and routing devices are configured to do things like bootp relay or IP helper, depending on your implementation, where it will turn around, take that broadcast, package it up in a unicast, and send it along. But to be honest, it still would look just like this one line for our purpose of client-server communication. So it runs what we just saw on the last slide, finds an available address and what options it can give the client, and it sends that back. Again, it would either unicast it back to the helper router switch, firewall, layer 3 device, which would then rebroadcast it back out to the client, or if this was all locally in a broadcast domain, it would just broadcast it, what we call a DHCP offer packet. This offers the client an address and the options it knows about to offer the client. Now, the way DHCP works is we didn't want to, how do we know that this is the right DHCP server? So there was always in the standard the possibility that we would have multiple DHCP servers that would offer the client an address and some set of options. So DHCP offers might be received from more than one DHCP server. Now, to be honest, it'd be nice if the clients had some logic and smarts and could say, hey, that had more of the options I wanted or less of the options I wanted, or hey, that 10-10-10 network looks suspiciously like my home network. There's not really logic in there. All modern clients, all clients for as long as I've been doing this, really just take the first valid DHCP offer. They don't really put any smarts into it. Why is this kind of a big deal? Most of us in the enterprise space, and for me who came from the network trade show and event meeting space, this happens all the time when somebody in a marketing booth plugs their home router in to try and steal more cables in the booth, and they don't know the difference between a WAN and a LAN port. Well, then your official server for the building is sending it, and the person in the cubicle who plugged in their home device backwards is dishing DHCP into your network. Anyway, client selects the first valid offer. That's what almost always happens. This is also why, even though they now have an address, they are still going to broadcast the request. Again, why are they going to do that? Because we need this to hit all the same DHCP servers who might have responded. Okay, so it's going to still be a broadcast at this point, indicating the server it is selected. So if the server was not selected, they didn't pick our DHCP offer, it returns that reserved address to the pool, ready to move on. If it was selected, the server offer is accepted, it marks the IP address as leased so we can start the timers, and sends unicast/broadcast fill ACK or a DHCP acknowledgement back to the client. Now, we know actually before this is done, we talked about reserves with the IP, this would ping the address to see if it's available, but we also know ping gets blocked in a lot of our worlds. So maybe it didn't respond to ping, but that client really is up. There is a final safety check. The client, almost all modern clients, will generate an ARP request to check that that IP address is not already in use on its local network. Most of us have seen a pop-up that says IP conflict detected, restarting DHCP. That message comes up because of this. Okay. So once the client does it, goes great. If it sees the ARP and the address is not in use, we're good, we use it. If it is in use, we actually send back a decline. All right. So thanks for bearing with me. I know the review is never the fun part. It's not why you really came here. Any questions on that? Has anything come in, Nalini or Michael? Because if not, this is a place where I will roll right on.
I think that would be good, Rob. There are some comments, but I think they're more in terms of comments and additional information. And maybe after go back through and look, but I think you're good to go.
Yeah, and I will say just the one comment from KL, yes, option 43 for wireless is probably the most common usage because it's the biggest vendor that does it. And sub option 241, I just happen to know it off the top of my head. I won't say who the vendor is. Yep. And their BOOP DHCP parameters. Yep, there's the great IANA page. Absolutely. All right, well, what you're all here for is what's new in IPv6. And let me just preface this to say that we only have 1 hour. So I am doing a tightrope walk here between telling you a lot and just giving you kind of all of what I think are the things to think about and go dig deeper on. So DHCP v6 is an updated DHCP specification, still in the DHCP working group. They're just RFCs that relate to IPv6, and it gets written into a number of the titles as DHCP v6. Okay, it was really first defined in RFC 3315, and I just have to point that out again just to say it's really pretty old. This isn't something new. It has since been superseded by 8415. Let me say there's also, I think, 5007, 6415. There are a whole host of RFCs that relate to DHCP v6. I got 2 mailings, and probably both Michael and Nalini did as well, because I still pay attention to the DHCP working group on DHCP v6 and the Yang model in the last couple days. So they're constantly being written. The ones where you're really going to go and get that sort of core information for what you need to know when you're starting to want to think through DHCP v6, because I will say the one relationship between IPv6 and DHCP v6 is you do want to think out DHCP v6 before you start making all your choices about how you're going to deploy your IPv6. Do you want to be routable? You're an enterprise, right? So we have sadly relied on NAT for things that maybe we shouldn't have. NAT isn't pure security, but it may be how we've built the rest of our security tools with this concept that our internal devices aren't routable or not easily routable. It certainly leaks. I'm not saying NAT is security. NAT is not security, but it may have played a factor in how we structured our security tools. So going and getting those basics for how DHCP v6 plays with IPv6, super important. Most of the things in 3315 are still absolutely valid. 8415 is sort of the more recent of the Uber standards. So that's how I would call it. The key thing, and I think this doesn't get talked about enough when you just discuss IPv6, is that there are really 3 types of dynamic addressing. And the first one is what almost everybody thinks of, and that's stateless address autoconfig, or we typically call it SLAC. And it was the big, especially early on, the big selling point of IPv6 of you don't have to IP address anything. Don't panic that the addresses are so long. You'll never have to manually address a client again because we have SLAC. And again, that's fine. That gets the addressing on without you having to type this potentially very long thing. But as we saw, DHCP really is much more about all of the other configuration. So then we have something called stateless DHCP v6. And I will say stateless DHCP v6 really is kind of the concept of using stateless address autoconfig, but using DHCP v6 for the options. And finally, the one that doesn't make a lot of sense in the world, but can make a lot of sense in our world of enterprise, and I'll say we used it for a lot of the IETF meetings because we had to be able to easily track people down. It's only a 5-day event, so we needed very clear addressing. So we would actually make people's v6 address match to their v4 last octet, so that we could easily identify, especially in a dual stack world, which clients were which. Okay, this note is old, but is still true. Not all operating systems support stateful DHCP-v6. DHCP stateful means DHCP gives out the address and it gives out the option. So that's the most like the IPv4 model. I say not all operating systems currently support. I didn't say not all current operating systems, okay? So this is that same problem, or we still have old operating systems out on the network. So you just need to be careful if you're going to deploy stateful DHCP-v6. And when you first deploy it, pay attention. If you're having people are having trouble, you may want to run and check if that operating system is fully supported for that implementation. Okay. Okay. So now we got to talk about DHCP-v6 and router advertisements, because that's really, router advertisements are really how Slack, the magic in Slack. So IPv6 router advertisements, it's not Slack or DHCP-v6. You still have to have router advertisements. And in fact, it's the beauty, whereas before you had to make the client either in how you built it, or if you're building a laptop, you had to go in and say, yes, I would like to do DHCP. You don't have to do that anymore. If a client does IPv6, the router tells the client how to get its addressing and its other configuration issue. We're gonna look at that. So router advertisements, or again, we call them RAs, have flags which indicate what type of dynamic addressing is valid for the network segment the client is attached to. So for stateful DHCP v6, it should be set as follows, and then I'm gonna walk through the 3 flags and tell you how you get Slack, how you get stateless, and how you get stateful. But for stateful, we have Slack, and we can make it disabled. Why are we disabling Slack, right? Because we're doing stateful. So we want DHCP to give both the address and the options. So we don't want it to get its address auto config from the router. Okay, so it still has to get the router advertisement, and the router advertisement says A, disabled. Okay, don't get your address from me. M, manage address configuration. DHCP v6 is available. This should be enabled. Notice this M is managed, but it's address configuration. And then O is other configuration. Okay, so if we were doing Slack and we didn't care about any host options, then we would just have A, and M and O would be disabled. If we want stateless, in other words, Slack gives the address and DHCP only gives the options, then it would be enabled, disabled, enabled. But you can do all of that with 3 flags. Again, I won't go into this crazy detail or talk about specific vendor rollouts, but this is kind of how we get all the different settings just with 3 flags. Okay, the next thing I'm gonna do is just, and again, I'm gonna go quick, we're like 20 minutes left, so I gotta hurry up. DHCP v6 doesn't really use MAC addresses. Now, it uses link layer, so MAC is in the link layer, but it doesn't use MAC addresses the same way DHCP v6 does. It doesn't send it to the DHCP server, okay? Instead, it uses a single DUID, DHCP unique identifier. These are defined in RFC 8415. That is an update. It was in 33. It was in the original, but you can just go to 8415. It's DHCP unique identifier. I'll just start saying DUID. DUID LLT, which stands for link layer address plus time. It's supposed to be generated and stored at the startup of that interface. Then we've got DUID EN, which is a vendor-based or on the enterprise number. We may remember that from our MAC address world. It's slightly different, but same concept. We've got just link layer without time. This one can be tricky, especially in things like VMs and that kind of stuff where the link layer gets generated out of a limited pool, but it's very similar to using the interface MAC address, and the DUID UUID, which is 128-bit universally unique identifier. Okay, universally for as long as 128-bit will be big enough, which is pretty big. All right, message transport. Since we talked about DHCP-v4 and how it was so much broadcast, so much layer 2, v6 is a layer 3 protocol. It starts layer 3, it ends layer 3 because the clients already have a working link local address before they send out their first DHCP v6 packet. So we don't have to play those games with layer 2 and then going to layer 3. We'll see, and in fact, because we do that, renews and has meant 3 different things historically in v4. We actually had to define what all 3 of those things are in v6. They already have a working layer 3 address. Okay. The ports have changed as well. So this is all done with multicast. Again, this came along much later. We had more sophisticated tools. So either the DHCP relay agents or the DHCP servers themselves listen on FF02::1:2. That's their multicast address. And all DHCP servers on the local site, so it hasn't been relayed to, listen on 05::1:3. Okay, so again, I'm not trying to go into incredible detail on this with us only having an hour, but I just want to point out it's very different. It's a layer 3 protocol. The clients themselves are going to listen on UDP 546, right? That's how they're going to send out to these multicast addresses, and this is, it'll come back to them, right? The way multicast works. All right. The messages I'm about to show them, let me just go ahead and click it, are from 3315, the ones that are shown on here. There are more that have been added in future RFCs. Again, some in 5007, then they were basically all redone in 8415. But these are tracked by IANA, and so I went ahead and looked it up a couple days ago. There are currently 35 DHCP v6 message types today, but these original ones covered the equivalent for v4. And since you may be way more familiar with v4 historically, the DORA packet, discover, offer, request, ACK, DORA, DORA, the DHCP Explorer, these are sort of the equivalent. And like I said, a request, which we typically call renew, right? Hey, I have an address, I'd like to keep it longer. Usually just was send a DHCP request and get an ACK. And this would start as a unicast, and when T1 expired, it would go to T2, and then it would fall this back to a broadcast. But a request is part of the initial. A renew is what we should do when T1 expires, and a rebinding, failing back to broadcast, is really what would happen after timer 2. So in DHCP v6, we were able to go, well, we only had called it one thing, but it was really 3 different happenings. So we gave it 3 new names. DHCP ACK acknowledgement, yes, you can have the address. Negative acknowledgement, no, you shouldn't take the address that other server gave you. That's somebody's home router in their cubicle, are both types of reply. We've got release, information request, decline. That's when I see, hey, you gave me an address I can't really use. We actually have a confirm message. This is a big one. It's worth looking up. What people have always wanted in DHCP v4 is a DHCP force renew, where the server could tell the client, hey, I've changed something in my IP phone configs. I would like you to renew right now. There is no mechanism for the clients to listen on v4 client for the server to tell it to renew. So it's going to run that lease until the timer expires, and that is the only time it's going to send a new request. Okay, so this has always been here, but it's never really been implemented. Reconfigure is very much more well-defined in v6, in DHCP v6, and we really knew why we needed it. And again, there are a ton more. A lot have to do with CPEs, cable modems, cable providers, multi-lease. Again, you really can go look in 8415. The other thing that's very different is options. I know we're behind, but I'm going to tell the cute story just because I know it made Michael happy when I told the first time. I was one of the, I had, because I build the network for the IETF, who was defining IPv6 and DHCP v6. When the very first implementation came out of DHCP v6, it was released about a week before an IETF meeting, and I was told I had to offer DHCP v6 at the IETF meeting. And the funny thing was, they gave me the code with DHCP v6 in it, and I said, that's fine, but I need to give out the name servers, and I don't know what this option looks like. Nobody had written this yet. And so the vendor I said, hey, you got to tell me what the options are and what the names are so I can write the config. And they were like, we're going to have to go look at the source code. So anyway, this again, this is published. You can go look for DHCP options. This is way longer than this. I just grabbed a snippet that would fit on the page and be readable. But like v4, it's an option code. Then there's a name to help describe what it is. And then there's what its type is. So the name servers is just an array of IP addresses. In this case, they're IPv6 addresses for the name servers. Okay. Start TLS, yep. 143 options, yep. Used to only be up to 128, and then IANA took the ones vendors were using back. All right, and we're almost to the next Q&A break, and I'll try and catch up on some of these Q&A because the last bit's security, and I skimp on that a little bit. I can hurry through that. 2 lifetime values with DHCP leases. So I'm not talking about the timers, these are lifetime values. So there's a preferred lifetime, and this was a very smart thing. Remember, DHCP is coming way later in our understanding of networks and the concept of flows and even software-defined networks. We're starting in, SD-WAN, we're starting to see those technologies coming down the pipe. So we have a preferred lifetime, and this is the length of time that a valid address can be used without restrictions. What does that mean? How it's supposed to work, I'm not saying every implementer does this right, I'm just saying how it's defined to work is when the preferred lifetime expires, the address becomes deprecated. What does it mean? It means it should not be used for new communications, but it may continue to be used for existing communications. Anybody who's tried to implement being able to sort of black hole a client or enforce a bedtime or end of work day, and you want to stop all communications, we know certain, short of getting a true high-speed NAT in the middle or a high-speed proxy in the middle, it's very hard to shut down an existing communication, right? We actually have to differentiate between say it's a bedtime enforcement for the children in a home. We can't just go, oh, okay, well, we're not going to do any new lookups. We're not going to build any new TCP connections. If you have something running like a YouTube video or something like that, something dynamic, we need to be able to catch that, stop that. So that is kind of the concept behind preferred lifetime, right? So we should not start any new communications with it, but we can continue using existing communications. This happens along the way. The valid lifetime is what we would equate to more of a DHCP lifetime, and in fact, it's the only one really in DHCP, and that's its lease time itself, and that's the valid lease time. That's the point where, hey, if you hit the end of your valid lease time, you should no longer be using that address. Now we have options along the way in our lease to renew our lease, but if we don't renew our lease, when our lease expires, that would really be the equivalent of the valid lifetime. There's some subtleties in that if you want to read up more, 8415, but these, we even have a new concept of preferred lifetime. Again, if you're rolling this out, just things you should really be looking at. But like for v4, there's 2 timers for DHCP leases. The one thing I'll say is they made the math much easier to remember. So there's T1 renewal timer. It's going to be a little different, right? Because a T1 renewal timer in DHCP is at what point do I unicast back to the server who gave me the address and say, can I keep this? Now, what if that server went away, right? So that usually happens at 50% of lease time. In this case, we send a renew. So that's the big difference here was it was unicast and it failed back to broadcast. In DHCP server, we are going to unicast. And again, now we have different messages, right? We have request, that's the first one. Then we have renew, which is a unicast back to the original server still. So this looks the same, and this is typically at 50% of lease time. Then we have T2, which is now we call the rebinding timer. This used to be the T2 renewal timer. And this was when we used to fail back to broadcast, but now we're going to go back to the rebinding message, and we're going to send it to any available DHCP v6 server. But how do we do that in DHCP v6? We do that through multicast. Okay. I will say the T2 timer in V4 was 7/8, which made doing the math on a 2-hour lease time totally a pain in the butt, 80% way easier. All right. So those are the big differences we have. Let me see, 143 options, yeah. And Joe, how are you? Bob Harold, last I heard, Android refuses support DHCP 6 as a matter of policy. I don't know if that's still true. I'd have to look, Bob. It would be interesting to me because Google is so, well, Google and the Android people both are very involved in the V6 world. It wouldn't surprise me because, you know, those groups never play nice each other without, how do I say this without getting in trouble with Nalini? The single largest maker of end laptop host OSs, that company is also hugely involved in the standards that their engineers hate to ever implement. So it wouldn't be out of the realm of possibility.
No, so Rob, I'm going to interrupt you for a second. And as far as I know, that is still true. And in fact, I wanted to, if guys, as I say, I think a number of us know some of the behind the scene dynamics of this, which I will not get into. But guys, this is something INTC really can potentially handle. And so if you guys would like to see Android support for DHCP v6 or anything else like that, please do send me an email, because I really feel like if we can speak with one voice and say we have, 25 organizations, of course we will not name them, we have 25 organizations who would like to see this, and we can even do a survey. So I think that would have some impact. You know what I'm saying, Rob?
Yeah. Oh, absolutely. And thanks, Joe, for confirming that it is still an Android problem.
Mike's going to jump on top of that too. Please do what Nalini said. If anyone has interest in DHCP v6 being on Android, it is currently a controversy in the 6-man working group at IETF, and there's an IETF meeting coming up where we can bring that up and say this is important to enterprises, which I think it is. And Nalini and I will be there to do that on your behalf. So sorry for the interrupt, guys.
Oh, no.
Absolutely. No, that's great. That's wonderful. Yeah, and we can take some people aside too and twist their arms. Mike's real good at that. No, I'm kind of teasing. I'll take Mike for a beer. So, one thing I'm going to say, just a little logistical problem as we're getting out of time. One of the things that I'm tempted to do at this point, because I really want to hear your DHCP security concerns, what I'm going to ask you to do is let's stop now, and I'm going to ask you to record your DHCP security concerns. You and I can get together offline. We can record it, and we can make that available. You see what I'm saying, Rob?
I do. The only thing I'm going to say is we have one question in the questions that is specifically answered. So I'm just going to answer it verbally. And then, yes, I can record these last, I think it's 8 slides. To be honest, and it takes 4 minutes, but I think we got some great questions. So, and I don't remember whose name it was, but the question was basically scanning tools of the networks for subnets in IPv4 is already interruptive enough, but when I'm trying to scan an IPv6 network to see who's there, and we will talk about more of this actually next week in IPAM, that is 100% the reason that at the IETF meetings where I was involved, and I won't even say what tools we're using, we purposely built it so that the IPv6 allocations mirrored the IPv4. So if I was in this, I won't even say what the first 2 octets of the IPv4 were, but say I was in the 37 network on .40, we would literally have you in our IPv6 space, : 37:40. That would be your IPv6 address. We would literally make them match because we couldn't deal with having to scan that network in the middle of the meeting. And that's just a meeting of I don't know, 800, 1,000 people. So, and I deal with Fortune 10 global customers. Obviously, you can't be scanning not even just a /64. What if it's /48 or 32? There's no way you can scan that. So in our world of enterprise, where scanning is maybe even a consideration, having DHCP-v6 doing the allocations, keeping them in those very more limited size pools absolutely is a huge thing.
So Joe, sorry, not Joe, Rob, sorry, I'm thinking about one person and back into the other. But Rob, this is something, so a bunch of notes here. So before we get, you, Mike, and I get off onto our round table, playing off each other, sparking off each other, as I call it, there's a whole bunch of discussions that we need to have around this whole thing, because Michael and I have done a bunch of things on address planning, but I really wanted, because I'm a little cognizant of the time, so I wanted to, because what Rob has brought up is an issue that really has a lot of ramifications. And,
yes.
And instead of getting the ramifications right now, let's talk about it offline, and maybe we can even have that can be part of the round table. But I wanted to encourage you guys too, is that we have 2 other recordings. We did a bunch of DHCP-v6 stuff in the past, and I'll send links to those as well when we send this out. And I see some other questions coming in, but I'm going to take one slide segue here, a logistical segue. I do notice that there's people from the Peace Corps on this call. We usually don't give a shout out to folks, but I am going to do that so guys, I was in the Peace Corps when I was young, and so for you guys, I'll do anything. Just contact me. You guys,
I will second that. That's great people to have here. Hey Joe, scan and blocking is automatic. I see that question. It's more a comment. We could spend an hour on that topic alone, and we'll come back to that a little bit when we talk about IPAM, and that's if I need that information overlaid with DNS and DHCP and a DDI IPAM kind of solution, then using the DHCP-v6 is certainly a better thing. If my DDI tool can do network discovery by talking to the layer 3 devices, it certainly can get it out of there because the network side knows it, but historically, the IPAM side and the network management side can be very different tools, and the DHCP DDI side may not have access to that scan and blocking that I think you're alluding to. So, but I agree, it was thought through, it just wasn't across sort of multiple subsystems within our networks.
So there's another question about DHCP for IoT devices. And one thing I'm going to say is I'm going to encourage you guys, we're going to have a whole set of sessions on IoT. And a lot of the folks that developed these, the base RFCs for IoT, Karsten, Pascal, Rahul, they will be on, Yorgos, they will be on talking all this stuff. And so really encourage that. Save that question for them too. Those are the guys to ask, not me. And so let's talk about that.
Accountable, Nalini, let me add to that. Hold them accountable that you need answers relating to enterprise, right? That's
there
what
you go.
We are set here to do for you, is to say, we've got these RFCs that aren't always really written around our use cases. How does this affect us, right?
But guys, that's right, Rob. But we need to do that too. But that's what they want to do. That's why they're participating with us. They're like, we want to hear your requirements. And so it's a great opportunity. So let's have a two-way conversation when that happens. And so in the interest of time, Michael, I'm going to give you a
presentation, right, Nalini? Just because someone's asking, William's asking, that the V6 for IoT or just IoT in V6, That's, you guys are going to put that on your calendar, correct? It's not a reference to edge computing.
No, that's correct. It's not a
Okay.
reference to edge computing. We may have some edge computing stuff, but that's no, we have IoT coming up. That's what we were, that's that. And so Mike, I'm going to give you one final comment, and then Rob, I'm going to let you wrap up, and then I'll close out. Again, wonderful presentation, Rob.
Yeah, and while Michael does it, just because I know they can email you, Nalini, in case they don't get to watch the video later, I'm just going to literally click through these so they've seen them. What kind of stuff I was going to be talking about, fingerprinting, and that was it.
And we'll make, but we need to spend some time, have you record that. People want to hear it, Rob.
Yep.
People want to hear it. Good. So Michael, you go ahead and wrap up, please.
Well, my comment is, Rob, you've done it again. You are fantastic. This is excellent information. The only caveat I'll throw on top of that for some people, that if you're blown away by what Rob's saying, if it's over your head or if it's premature for where you're at on your IPv6 journey, yes, then that's going to be the case for all of us. But hopefully we'll have this session recorded. We'll be able to save the slides, and there will come a time where this will be a godsend for all of you. For now, as you start your journey, do some really good address planning, get your addresses, and then that will help you map out what your DHCP-v6 deployment should be and how that should interact with Slack and anything else you might be doing in that space. But once again, Rob, thanks so much. This was so good.
You bet. And actually, Nalini, just occurred to me, if people want to step away, if you want to stay, and I'll present these now, then when we do the editing at the beginning, they can glue it back together.
That is perfect. That's just, that works for me.
Right.
So guys, that makes it easy. So guys, if anybody needs to step away, please do that. Otherwise, we'll go ahead and edit this, and you'll get the whole presentation without, and we'll make these questions go at the end. And if you can stay, then Rob's going to go ahead and do the rest of his presentation, which I'm really looking forward to.
Awesome.
So go ahead, Rob.
All right. And like I said, these will go pretty quick because a lot of what I'm going to talk about here really comes back next week in IPAM. We'll spend more time on security in IPAM. So the thing I like to say, and this is DHCP, whether it's v4 or v6, obviously we kind of have more historic tools for v4, is that DHCP is often the first contact. So when we're in an enterprise world, the first sign that someone has on the network, right? Short of a real, layer 2 NAC solution, v6 has its own, NAC first entry. But if I don't have it really at that core layer 2, layer 3, then DHCP is often really the first sign that a new host has come on our network. So my argument is always, let's check them at the gate. So like a bouncer at a nightclub, they stop, they check your ID, they make sure you're old enough. They do some basic checks. They still send you in. There's still security in the club. But I like to think of DHCP when we're talking about network security as sort of first gathering of information. The reason I bring this up is we have relied as network operators, as DHCP is something that takes work from us and gives information to clients. What we fail to remember is that clients give a lot of information to the server. A lot of what we would consider very valuable in the security SecOps space, information about the clients, right? Forensic information. They tell us their host name. Almost every client does today. It used to be very Windows centric did, and Unix and Mac flavors didn't. That's not really true anymore. Most modern clients either do give up host name by default or can very easily. We have that parameter list. I told you the clients say what options they want. And this is interestingly, not only what they ask for, but in what order they ask it for is very specific per client type. And we'll look at that in a second. They give up a client ID and even a class ID. So somebody had brought up wireless phones. How we know to give the wireless phones the option 43 specific vendor specific options, because you don't want to leak that out to every client on your network, is those particular wireless access points. Those wireless access points say, hey, I am a blank vendor AP number, and we can match that and go, oh, if it's that kind of AP, tell them that the wireless manager is over here. Okay, so we get, and then also option 81, which is where the client can define its whole fully qualified domain name instead of just jamming together what is the host name and then what is the domain name glued together. Okay, so we have fully qualified domain name. So we can get a lot of information, and I bring that up, and I apologize, it's a little small as I see it on my backup screen. We typically, as network operators, only look at what do we offer to the client, right? So here we can see what are the options we're offering. But the client actually asks for way more than we offered them. So looking at what's in the Discover packet, again, this is V4, and I'll talk about the V6 here in just a minute. This can be hugely valuable to us when we're talking about network security, in knowing what kinds of clients do I have on my network, what kind of clients are on that one specific network. Again, this is where shrinking those V6 ranges can be very helpful. I can also, if I know what kind of clients they are, I can actually create ranges where IoT devices go, ranges where laptops go, ranges where cellular phones go. So again, taking DHCP, it's not going to be perfect. This is just that sort of first contact. We still need security in the building, but we can certainly gather a lot of forensic information, have a much better knowledge of what's on our network if we take advantage of what's already in DHCP. So DHCP fingerprinting is a tool, and I'll talk more about how it works. This is just what order the clients ask for options. So I think there's a couple interesting things to point out here. One, I will just tell you, these are all the same sort of client type, and these are the same client type. But what's interesting is notice that they don't get sorted, and this can be taken straight out of a packet capture, or it's in DHCP if you do IPv6 all and those kind of things, or if you track the DHCP, you can certainly see it. They're not in numeric order. These are what order the vendor suddenly realized, oh, now we've modernized this client. So their old version went up to here. Then they said, oh my goodness, we need to add 31 and 33. And then in another version along the way, they got 49. And then they were like, oh, we need 43. This order makes a difference. This can totally, you can have the exact same options asked for by the client, but the order different may make a big difference. So I'll just tell you, because I happen to know, these are all flavors of Windows XP. These are flavors of iPhone. And this is an old slide, so these are very old, original iPhones. This is a much bigger list today. So that's what DHCP fingerprint does. And instead of you having to do this, a lot of implementations today can implement known signatures. And the signature isn't just the client request list, parameter requests. It's a little bit more. The MAC address, so in V4 gives us some very limited information, especially based on the vendor OID. Client often provides information about its OS and device type. The host name can give some stuff away. The option sequence, like I said, what order those are in, that option 60 vendor client ID, or even 61 class ID. So again, 55 or 60, 61, we can infer the OS and device type. They're then put into a DHCP fingerprint that when I go and I look at my tools, we'll come back to this in IPAM and go, oh, what's on this address? Oh, it has this host name. These are its DHCP least specific things. What are its timers? What's its state? But I can also then do a DHCP fingerprinting. Most DHCP implementations today will allow you to then do filtering based on fingerprints. So I can say, so for this pool of addresses, allow, you know, XP, Windows 7, Windows 8, Windows 10, Windows 11, Mac OS X, this, you know, all my sort of desktops, but don't allow iPhones, Androids, Samsung, all these other fingerprints we know, don't allow them in that pool, put them in this other pool. That way, again, I can separate out device types. It does work with IPv6 clients and DHCP v6. I'll just say less fingerprints are currently documented as more clients V6 and DHCP v6 clients become more known. It's always growing, but certainly it jumps. It came way after, as we saw by RFC numbers, so it isn't quite as accurate. Still helpful though, that's my argument. This is a real use case. I rolled this out for a university campus. They wanted to separate out the handheld traffic from the laptops on the university wireless. And then within the dorms, they absolutely wanted to block gaming devices. This is old, they now allow gaming devices. But so we filtered handheld devices to specific ranges of IPs. The other thing they did is at their layer 3, they did bandwidth shaping to then prefer those ranges, because we were able to separate out and go, the handhelds are here, the laptops are here. They were able to do QoS to give preferential bandwidth to the laptops. And then they just straight up block gaming on campus wireless. If you wanted to play games in the dorms or on campus, you had to request a physical port. So just one interesting use of DHCP fingerprinting. And again, a lot of how that fits into our security we'll come back to when we talk about IPAM in 2 weeks. And with that, this is where we will play the questions we've already answered. If I don't have any new ones, by the way, almost nobody left. It's pretty funny.
You're good, Rob.
And
We
Joe,
love
you're
you.
welcome for the DHCP rant. I am always happy to rant about DHCP.
All right, guys. So thank you again, Rob. This was wonderful. We'll go ahead and do a nice little edit for for things, and then send it out. So next week, in 2 weeks, we have IPAM. And if you have thoughts, anything else, please send them to us. And thank you again, Rob.
Yeah.
Fantastic presentation, Rob. Thank you so much.
Always great to share this time with you too. And with all of you, and they're basically all still here, so that's fun.
You're riveting.
Yep.
That's Rob. You are just great. Okay, thank you guys.